Purple. Why?
Because it has potassium.
Okay, potassium permanganate, and it is very hot. Okay, I cannot touch it. Okay, I am going to put it in here. Okay, at the surface. Okay, let us see what happens. This is very hot. It is expected to come out, and this water is cold, and it is expected to go inside the bottle. It may fill. Okay, let us see what happens. Okay, but provided turbulence is not there. Turbulence is not there.
Well, I could dance all
Churning
night.
is not there.
Well, I could dance, yeah. Well, I could dance all night. Well, I could dance, yeah. 1, let's have fun. 2, me and 2, 3, we are free. 4, give me more. 5, just alive. 6, take some ticks. 7, sing forever. La 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 like it. La 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 like it. La la la. इसके अंदर भी ज़्यादा hot वाला ऊपर है, कम hot वाला नीचे है.
Yes. Thermal energy wants to travel in liquid, especially. It doesn't travel alone. It travels with the particles. It sits on the particle and travels. Like you sit in car and travel, na? Thermal energy also travel like that. Yes, Venkata, what are you doing?
We are taking a glass of cold water, hot water, and water from tap water. We are measuring there. We are measuring each 3 glasses. This is hot water. This is cold water. This is the tap water. The cold water stayed on. It was in 10 degrees, and now it has increased to 23 degrees. Now its surroundings is not letting it increase further. Initially, we had the temperature of 10 degrees Celsius, and it started increasing to 22 degrees Celsius, and it increased to 23 degrees Celsius, and it kept there, and it had been still.
Gurveer, what is the role of this water?
The water is acting as a medium in those 2 glasses.
These 3 glasses were measured at after some time. Now, this all types of water is now coming to the same degrees. So, the T is 23 degrees, the S is 23 degrees, and the TH is 24 degrees.
So all kinds of waters have achieved same temperature.
Yes.
Okay, they are no more changing.
Yes.
Okay.
This is the temperature of hot water, cold water, and the sink water. And this red water is a hot water, and this is sink water, and this is cold water. And the hot water is decreasing 73, and it becomes very fast. The slope is about 135, and it is very fast. And this is sink water, which is cold and increase temperature and slowly decrease. And this is the cold water. It came to the normal temperature by slowly, and after that it came to the normal temperature. This slope meaning in this graph of this hot water is the rate of decrease of temperature, and in the starting it decreased very fastly, and it started decreasing slowly.
The meaning of the slope in the red graph means the rate of cooling. The temperature of the red graph was 73 degrees Celsius, and it was able to give the heat energy till it came to the room temperature. After coming to the room temperature, it didn't have sufficient heat energy.
This shows the variation in cold water's graph. At first it was 10 degrees, and it slowly came to the room temperature, which is 24 degrees or 23 degrees. It increased in temperature very slowly because the temperature between the room temperature and the cold water is very less.
This is the hot water. This is its initial temperature. So due to the more difference, it was rapidly decreasing. This had less difference, so it was decreasing, increasing slowly. Like when it came down, when the difference was less, then its slope was less. It slope means that it was cooling very slowly. So when it was cooling slowly, that time the temperature difference was very less according to the medium, and the temperature of medium first went high because hot water was very hot. It was very hot, and cold water didn't have much difference. So first it went high. When the hot water became a little cool, then it came down. This graph shows us clearly that if there is more temperature difference between the sink and the source, then it will decrease rapidly. It means it depends on the difference. Like the difference is more here, so it is decreasing very fast. Here difference is less, so it is decreasing slowly. Its slope has reduced.
What are you doing?
Okay, we have taken a glass of hot water and we have covered it with bad conductors paper.
We have taken a glass and we have kept a paper around it, which is a very bad conductor of it. And we have poured hot water in this glass, and we are measuring the temperature, initial temperature, and how much it is decreasing. We are measuring that. Our friends are also doing that. Comparatively to them, it is decreasing very slowly.
What are you doing?
We have taken this glass of hot water, and we are measuring how the temperature is decreasing every single minute. We are writing our records in this book.
Yes. What are you doing, Gurvi?
We are measuring temperature of this water. This water was at some temperature. What was the temperature?
89 degrees.
89 degrees Celsius. On 89 degrees Celsius it was, and we have turned on this fan so that it reduces, and we are measuring the temperature every 1 minute.
Chinu, what you found?
I found that in the starting it was dropping very fastly, like 6 degrees in a minute. Like you can see here, 8 is the time 8:06. It was 89 degrees Celsius, and in 8:07 it became 81 degrees.
We have kept two glasses, glass 1 and glass 2 nearby.
Glass 1?
This is glass 1 and this is glass 2. The difference is that glass 1 is covered with some bad conductor so that the heat does not escape from the glass, whereas glass 2 does not have any covering on it, and both the glasses are kept under a fan that is not working.
Why have you kept your fan off intentionally?
So that the temperature does not decrease very fast every minute we are measuring the temperature. Because in glass number 3, they have kept the fan on to see how much the temperature reduces every minute. To see how much the temperature decreases every minute. So that the temperature reduces fast, we have kept the fan on here, whereas in glass number 1 and 2 we have kept the fan off. So by deleting the fan, we have actually tried to delete the convection and minimize it as much as possible.
This graph indicates the rate of cooling in different conditions. Glass number 1 is red color. It was covered with insulators and the fan was off. The glass number 2 is the gray one, which is here in the graph. It shows a glass which is kept openly with fan off. Glass number 3, the green one, shows glass without any indicators. It was kept openly with forced wind. Cooling is fastest in convection, that is with the forced wind, and it was the slowest in the one with when the glass was covered with bad conductors. Bad conductors of it
so they didn't allow the heat to escape through them. So it was difficult for the heat to escape out. Whereas in glass number 3, that is through convection, the air was also moving, the air was also going, so the rate of coolness was fast.